So live from Mars Future Medicine 2009, this is John McCulloch from Mars. I'm joined by Dr. Mick Bhatia from the McMaster Stem Cell Group. So great to see you, Mick. Thanks for taking the time.
Thanks for having me.
I'd like, first of all, so our viewers can get an idea, if you could describe a little bit about your background, your current research, and maybe some of the major discoveries you've had out there in Hamilton.
No. Well, my background is really in hematopoietic blood stem cells.
Yeah.
And we spent a lot of time early years development of our lab trying to expand those cells to improve bone marrow transplants. When the description of embryonic stem cells or pluripotent stem cells in the human came along, we thought, well, in addition to try to expand those cells, maybe we can come up with an alternative source to increase their numbers and make them available for clinic, for people to use. And that's where we really got into and where we're at now, where we're spending most of our time trying to understand induced pluripotent stem cells, a discovery made by Yamanaka in Japan, and how we can encourage those cells to become blood as an alternative source to things like bone marrow.
Absolutely. That's very interesting. And one of the important features that your facility offers is you have the capability to do industrial scale research, I think it's fair to say. You have robotics capability, high throughput capability. Could you talk a little bit about that?
Absolutely, yeah. We started off our work like many others, and we have collaborations all over, trying to understand how do you differentiate these cells for blood in a better way. A lot of that's based on a candidacy approach, but not on a discovery approach. So we tried toward the idea of applications, we automated our process. So it wasn't limited by the number of technicians or students working on a set of projects, all based on candidate proteins. We decided to look at all sources of chemicals, bioactive novel libraries that are used to find antibiotics or things like cancer therapeutics. And we've scaled it up so we can use induced pluripotent cells from human, put them in an automated screen where a robot changes the media, adds the molecules, but also the robot positions it in front of a microscope that tells us, have the cells changed? Have they formed blood or have they not? And I think that's critically important to really come up with some new ideas of how these cells can differentiate. But also some of the compounds can be modified, and we think they can be modified in a way to create drugs that might be able to be used to induce your own cells to create more blood without actually even requiring a transplant.
Right, excellent. I mean, it's no coincidence, I guess, because McMaster University is one of the largest compound libraries of any public institution in Ontario, so it's a very good fit between your primary screening capability along with the resources that are in place there.
Yeah, absolutely.
I could likely guess where you would like things to go, but what would you say are the main fruits of the research that you would like to see? What would you like to see coming out of your work, maybe within a 5-year horizon?
Yeah, I think, John, a 5-year horizon, what I would call near term. I think right now we're very close to try to, making improvements to generate blood cells from these pluripotent cells, and that alternative source is key. I think by using combinations of things we know, things we have yet to discover, we'll be able to make large quantities that could actually be ready for real-time use in the clinic. I see that coming hopefully very soon. All the bone marrow transplantation is already in place. So I think from a cell replacement therapy point of view, this is the most likely use of these induced pluripotent cells.
Oh, great. And one aspect also that obviously comes up a lot in relation to any application of stem cells in a clinical setting is safety. And your group has also been able to identify, correct me if I'm wrong, which cells have the potential to become teratogenic or cancerous and which ones do not.
Yes.
Could you talk briefly about that?
Yeah, it's an important phenomenon. I mean, one of the things we love about stem cells is they divide and make copies of themselves. Unfortunately, that same property is what you see in cancer. The difference is cancer cells don't know when to stop, and stem cells should know when to stop. We created a series of tests, essentially litmus tests that were very easy, very transferable to multiple labs that could do it without huge expense or technology development, that could tell the difference between a cell that was acting like a cancer cell and therefore wouldn't be safe to discover drugs on or to
Yeah.
transplant because it's behaving poorly, behaving like a cancer cell, versus when the cells are acting normal.
Yeah.
I think that's an absolute critical step to validating the drugs that we're trying to look for, or drug candidates we're trying to look for, but also to make sure that we mitigate any risks in cell transplantation, which I think is on the horizon.
Oh, great. The last thing I'd like to touch on is that it's increasingly the case that both at the academic level and also within industry, that we're starting to see the emergence of multi-center collaborations develop, simply to ensure that the resources that are necessary to achieve the goal are addressable. Can you comment what changes you've seen in terms of collaboration, both academically or even industry interest in your work?
Yeah, absolutely. I mean, like I said earlier, one of the things we're interested in is improving differentiation through novel chemical compounds. And so what we've really done is capitalize on strengths from completely other disciplines, working with chemists that know how to do this very well, and,
Yep.
and they're the source of the compounds, working with stem cell people that understand the biology, like myself. But to automate anything, you require engineers. When you get that kind of information from automation, you've got to collapse it into something that's meaningful and can be quantitated and compared between one compound to the other. That requires mathematicians and
Right.
computational capacity. So we've been working very diligently with groups regionally here in Ontario with Waterloo, the Perimeter Institute that has incredible ability in bioinformatics and mathematics. We've been working with the engineers to try to understand the automation component. And obviously the chemists and medicinal chemists now at the Ontario Institute of Cancer Research that have just been launched through Tom Hudson to try to move all of this forward. I think the problem is a big one to try to bring stem cells to the clinic, and I think we need multiple disciplines to bear on it. And Ontario has certainly served with McMaster as a great way to do that.
Yeah, fantastic. Well, Mick, thanks very much. That was really great.
Thanks,
Thank you.
Okay.